Hello everyone. Today I'll be going through Hess's law covered in NCEA Level 3 Chemistry. This will be in two parts. For this video, I'll be going through the 2018 past paper on Hess's law, and next video it will be the 2023 past paper. So, Hess's law states that the total enthalpy change of a chemical reaction is the same regardless of the pathway taken, as long as the initial and the final conditions are the same. What this is saying is that if I were to go from A to B, it will have the same total enthalpy change. Then, if I go from A to C to D back to B. So yeah. This is essentially what Hess's law says. And looking at the question, the equation for the formation of solid Al2Cl6 is this equation. And we're asked to calculate the enthalpy change for this reaction using these four reactions given. Essentially, what our goal is to manipulate these four reactions to ultimately form this reaction above. Alright, so let's have a start. We can start with any of these four reactions, but I will start with the first one because it has the most things that matches with the equation above. This includes the 2Al solid and the Al2Cl6. So let's write this down. 2Al solid plus 6HCl aqueous going to 2Al2Cl6 going to Al2Cl6 aqueous plus 3H2 gas. A trick in doing these questions is always keep an eye on what I want and what don't I want. So I want the 2ALS because it matches. I don't want the 6HCl aqueous. I do want the Al2Cl6, but and we don't want the 3H2 gas. But now it comes to the second thing we need to keep an eye on, which is what form is it in, what state is it in. We want the 2Al and it is in solid state, and so and it is also in solid state for the reaction above. But for our Al2Cl6, we're in aqueous form, whereas in the equation, it's in the solid form. So we must do something to it to get it back to solid form. Right. So, first we need to remove the 6HCl aqueous and the 3H2 gas. And we also need to change this into solid. So that's our goal. How do we remove species in the reactant side and the product side? It's not hard. If we were to remove 6HCl from this equation, we will want another equation which has 6HCl aqueous on its product side, so that the reactant side's 6HCl can go. Because if I go from HCl to HCl, this isn't a reaction because nothing reacted, right? So these two can cancel out. So that's how you take away. So now we will want a reaction with H2 on the reactant side and HCl on the product side. And which reaction satisfy that? It will be our second equation. So this is our first and this is our second equation. Second equation has H2 on the reaction side and HCl on the product side. So let's write our second reaction or equation down, which produces 2HCl. But look, this isn't gaseous, but this is aqueous. So we must adjust this into aqueous in order to take HCl aqueous out in the first reaction, right? So how do we do this? We'll use the third reaction, which is HCl gas going to HCl aqueous, which is what we want. And essentially what we're trying to do to reaction 2 is to remove the HCl gas and then add on the HCl aqueous. And we can do this by just adding on the third equation, which is HCl gas goes to HCl aqueous. Now look, if we added 2 times, this and this cancels out, and so we're left with 2 HCl aqueous on the product side. So essentially this gives H2 gas plus Cl2, or Cl2 gas, missed the 2, and this gives 2HCl aqueous. And now we have to calculate the enthalpy change of this reaction. So for reaction 2, our enthalpy change is -184, and we need to add the enthalpy reaction enthalpy change for equation 3, which is -72.4. So we take away -72.4 because we're adding a negative. But is that it? No, it's not, because look, we added it 2 times. So we need to multiply our reaction 3 by 2. And this gives -184 minus 2 times 72.4, which is minus 328.8 kilojoules per mole. Right, so let's call this reaction 5. And now we can use reaction 5 to manipulate reaction 1 in order to remove our 3H2 gas and our 6 HCl in aqueous form. So let's do that. We'll do 2Al solid plus 6HCl aqueous goes to Al2Cl6 aqueous plus 3H2 gas. And we'll be adding on reaction 5, which is H2 gas plus Cl2 gas going to 2HCl aqueous. And how many times do we add on 5? We'll add it on 3 times because we want to remove 6 moles of HCl aqueous and 3 moles of H2 gas. So we're gonna put a 3 in front of everything, and this becomes a 6. And this equation gives us 2Al solid plus the 6HCl and 6HCl cancels out, and the 3H2 cancels out as well. Plus, so this is plus the 3Cl2. And this goes to Al2Cl6 aqueous. And the reaction enthalpy change for this one is, let's see, our first reaction has enthalpy change of -1003, and our reaction 5 has enthalpy of -328.8. We're trying to add these two enthalpies together, so we're adding a negative, we're just taking it off. And this is also not it, because we added it on 3 times, so we must multiply by 3. And this gives us -1003 minus 3 times 328.8, which is minus 1989.4 kilojoules per mole. Right. Now let's check what do we like and what don't we like. We like this. We like this 2ALS. We like this 2Cl2 gas. We don't like this aqueous. So we're gonna turn this Al2Cl6 into a solid. How do we do that? We will use the fourth and final reaction. But look, this reaction goes from Al2Cl6 solid to aqueous, but we want it the other way around, from aqueous to solid. So, if I go from if going from solid to aqueous has enthalpy change of negative 643, then going from aqueous to solid will give me an enthalpy change of positive 643 kilojoules per mole, of course. So for we'll be essentially minusing off reaction 4 from this reaction. Let's call it reaction 6. Alright? And this is reaction 4, we're minusing it off. We're minusing Al2 Cl6 solid goes to Al2 Cl6 aqueous. If we're minusing that off, we would get, think of a negative here and a negative here. So these two will cancel out, and this, if we minus a negative, it will become a positive. So this negative Al2 Cl6 solid that we minused off from the products, from the reactions, will go to the products. So this will give us 2Al solid plus 3Cl2 gas goes to Al2Cl6 solid. And this has a reaction enthalpy of so for reaction 6 we have negative 1989.4, and we're going to add on the enthalpy change of reaction 4, which is negative 643. But negative 643. But we put a negative at the front because we want the opposite of reaction 4. We want to go from an aqueous to a solid, not from a solid to aqueous. So this negative becomes a positive. So essentially we just put it as a positive. So we have negative 1989.4 plus 643, which gives us negative 1346.4 kilojoules per mole. And this, you don't have to round it, you can round it. It's good to round it. I'll round it to 3 sig figs, which is 1350 kilojoules per mole 3SF. And this will be the whole run through of the question. Yeah, thank you.